can you tell Kelsey to speak in English? Or let me go to the bedroom. Shut. That's my time to score. Shh. Pass. Shh. Miss. No, I can miss. How's that?
Bends its wings several meters in flight. It can evacuate every single passenger in just 90 seconds. An aircraft where you can take a shower at 40,000 feet, have a cocktail at an actual bar,
No.
fly halfway across the planet without ever landing. But here's the most surprising part. This engineering giant nearly destroyed the company that built it. This is the Airbus A380. By the end of this video, you'll understand why the largest passenger aircraft in history is also one of the most fascinating paradoxes in aviation. Stay with me, because some of these facts will completely change the way you look at this plane. The first thing that sets the A380 apart is pure scale. Its maximum takeoff weight reaches around 575 tons. To put that in perspective, that's the weight of a fully loaded freight train several dozen cars long. The wingspan is nearly 80 meters, comparable to the length of a football field. 24 meters, like an eight-story building. But the real defining feature isn't the size, it's the architecture. The A380 is the only airliner in the world with a full-length double-deck layout across the entire fuselage. On the Boeing 747, the upper deck covers only the front section.
The team Ronaldo.
It's essentially a flying multi-story complex, and all of this lifts off the ground thanks to aerodynamics.
Nimeshasimamisha.
That architecture translates directly into capacity. In the certified single-class configuration, the A380 can carry up to 853 people. That's an absolute record for passenger
Daddy, hini ya Real Madrid.
Commonly, it's 450 to 600 passengers across
Hata
3
kuna
or 4
TV.
classes.
Na mbona imeleta hapo the word video.
On a single aircraft speaks to the project's
Imeandikwa
scale.
earbuds.
One flight can transport as many people as live in a small village. And this wasn't just a matter of adding seats. It meant recalculating everything. Floor loads, emergency exits, life support systems, cabin pressure, air conditioning, power supply, baggage compartments, from the ground up.
Dad.
The A380 was designed to move massive passenger flows between major hubs. And in terms of raw capacity, it remains unmatched to this day.
Unajua mimi nina train.
With all that size and weight, you'd expect the range to be
Niko
limited.
ready
It's the
kutrain.
opposite. The A380
Dai, mbona
can
venye
fly up to
naenda?
9,000 nautical miles, roughly 15,000 kilometers depending on the version and payload, without a single stop for refueling. That translates to ultra-long-haul flights over 17 hours, on routes like Singapore to Los Angeles or Dubai to New York. Cruising speed is around 900 kilometers per hour at an altitude of 12 to 13 kilometers. At those altitudes, the air is thinner, drag is lower, and efficiency climbs
Hiyo
dramatically.
airplane
The secret
kenye
isn't just
inatwanga
fuel,
vitu
it's
tunaionanga.
aerodynamics. The A380's massive wing
Inakuanga
generates
kadogo.
enormous lift
So you
with
see,
relatively low specific fuel
unaweza kuta
consumption.
inakuanga kubwa.
And here's a
Hiyo
counterintuitive
ni kama hii. Ni
The
vile iko
longer
juu
the
ni
route,
kama
the more
hii sasa.
cost-effective the aircraft becomes.
Tututututu.
Takeoff is the
Sasa
most
hii ni
expensive
kubwa
phase in
sana.
terms of fuel. Once the A380 settles into cruise mode, it sips fuel far more efficiently than
Tunaona
most people
zinatoa
realize.
hizo.
That's exactly right.
Kama ile airplane kene
As an
tunaona.
intercontinental giant for transoceanic flights without intermediate stops,
Hadi kuna macho.
the numbers are staggering. The A380 can take on approximately
Dad!
300,000 liters of aviation kerosene. At full capacity, that's fuel alone weighs about
Jet
250
fuel.
tons, nearly half the aircraft's total takeoff mass.
Naishi
Fuel is stored in the
inaenda
wings
for
and central fuselage. And here's the fascinating part. The distribution isn't static. Specialized computers constantly transfer fuel between tanks in flight to maintain perfect balance. Full refueling can take up to 3 hours and cost over $200,000, depending on kerosene prices. But when you calculate consumption per passenger, the A380 suddenly looks very different. Thanks to the huge number of seats, specific fuel consumption per passenger kilometer can actually be comparable to much smaller airliners. But maybe the most visually striking part of the A380 is something most passengers notice through the window: those massive wings. In flight, the wingtips can flex upward by about 4 meters under heavy loads. And that's completely intentional. If the wing were rigid, shock loads during turbulence would concentrate at the wing roof, accelerating material fatigue and eventually cracking the structure. So engineers deliberately designed it to flex. During certification testing, the wings were loaded to 150% of their normal operational limit. In one test, they were bent more than 7 meters upward before being pushed to destruction. Wing flexibility isn't a sign of weakness, it's a mark of thoughtful engineering. It distributes load along the entire span, reduces peak stresses, and extends the life of the structure. So next time you see those wings flexing in turbulence, that's not danger. That's the design doing exactly what it was built to do. That is incredible.
The global LNG market has changed dramatically in the last 25 years. If you want to really identify a significant catalyst for change, it was the entry of the United States as a
As impressive as the aircraft is, it has one major limitation. The world wasn't actually ready. The A380 is so large that not every airport can service it. Operating one requires reinforced runways, wider taxiways, enlarged parking stands, and special jet bridges with 2 levels. When the A380 entered service, dozens of major airports worldwide had to undergo massive upgrades. Some spent hundreds of millions of dollars on gate and infrastructure reconstruction. Even today, only around 130 to 150 airports in the world are technically ready to receive the A380 without restrictions. This was one of the biggest factors that limited its adoption. And the aircraft itself is just as complex to build as it is to accommodate. A single A380 takes roughly 3 years from the start of component manufacturing to final delivery. Sections are produced across several European countries: wings in Wales, fuselage sections in Germany and France, tail assembly in Spain. These enormous parts are then transported by sea and along specially built routes to Toulouse, France, for final assembly. The final assembly process alone takes months, with thousands of specialists working on a single aircraft. In total, the A380 is made up of more than 4 million individual parts, supplied by roughly 1,500 companies worldwide. It's one of the most complex civilian engineering projects in history. Despite all that size and complexity, the A380 still has to meet the exact same strict safety standards as any other passenger aircraft. Under aviation regulations,
This is
fully
National
loaded
Now. It's the
planes
Google
and fully
4-4-1-2
evacuated
formation today. A balance liner bolstered
half the
alongside
exits
partnership
considered
with
flawed.
Front. All
In
interception.
2006, Airbus conducted a certification test with 853 volunteers and 88 seconds for a limited light with some emergency exits closed.
Moving down the
12
flanks here.
seconds under the limit, that single test proved the world's largest passenger aircraft could meet the same safety bar as everything else in the sky.
They can do better
And
later
here's
on.
something that genuinely surprises people. Despite its size and 4 massive engines, the A380 turned out to be one of the quietest large airliners ever built. Airbus invested heavily in aerodynamic wing optimization and engine noise reduction. Compared to previous generations of wide-body aircraft, noise levels during takeoff and landing were noticeably reduced. Many airports reported a drop in noise complaints after the A380 entered service. Inside the cabin, passengers consistently described the atmosphere as remarkably quiet compared to older jumbo jets. So with all this engineering brilliance, you would expect the A380 to be one of the most successful aircraft ever built. It wasn't. In fact, it nearly became a financial catastrophe for Airbus. The program was originally estimated at around 11 billion euros. By the mid-2000s, it had blown past 18 billion. Production delays, wiring problems, and the complexity of coordinating international assembly led to years of delivery postponements. In the end, Airbus delivered only 251 aircraft when they originally expected to sell far more. Despite the engineering mastery and the love passengers had for flying on it, the A380 program was never able to fully recoup its development investment. Production officially ended in 2021. And maybe that's the most interesting lesson of all. The A380 is an engineering masterpiece, whose came a machine that pushed every limit of what a passenger aircraft could be.
By far the better
But it
team,
proved
and
something
they've got the
uncomfortable
owner
about
to show
modern
for it.
aviation. Technological greatness doesn't automatically translate into commercial success. Sometimes the most ambitious thing you can build is also the one the market wasn't quite ready for. The A380 didn't fail because it wasn't brilliant. It was too brilliant, too big, too specialized, too ahead of an industry that was quietly pivoting towards smaller, more flexible twin-engine jets. And if this video gets a green light, I'll release a
First half
follow-up.
ends and it's 1-0.
Another 10 incredible facts about the
That could all
A380.
change in the next
And if you
45
write in the
minutes.
comments that you want a continuation,
They're winning at the
20
halfway
facts about
stage.
the Boeing
Can they see out
747,
the rest of the game?
and there'll be no fewer surprises.
Great dribbling. That's nicely played. The passing has been pretty poor today. And moving the ball forward. He dribbles the ball forward. A determined tackle. Need to defend well here. He's charging down the wing. Careless pass there. He's got control of the ball. And he fires wide into the side netting. Can he take charge and change the game? Menendez. Good ball control. What a chance! Oh, so close there. What is up? The new players coming on. What a well-timed tackle. Surely now, he should do better. Clears the ball to safety. Menendez! What a finish! That goal, his second of the match. That's a goal he'll want to see again and again, and a short strike from this great player. What a hit! Just look at the power behind that shot. his tactics. His team are looking good today. He misjudged the pass. Well, you have to say there's not much chance of a comeback here now. Finish was just off there, and it's wide. Oh, that's well played. This is a physical game, lots of tackles being made. There we have it, full time in this friendly, but the true tests are still to come for this team. Well, for me, that's the correct decision. He's put in 100% and gets the Player of the Match award.
One, two, three, four.
Ushamalizia?
Recording.
Sasa kwa